For the last year, AI development has operated largely on intuition. Now, building custom AI behaviors is adopting the testing requirements of software engineering. Under the old workflow, you wrote instructions for a custom skill, fed the model a few prompts, and eyeballed the results. If the text seemed better, you kept the skill. The entire process hinged on human judgment. Relying on an output that feels better is a subjective and unreliable metric for system architecture. Vibes do not scale. Anthropic's new Skill Creator update eliminates this ambiguity. It forces every custom skill to show its operational utility before it enters production. Trial and error prompt engineering is being replaced by a pipeline that mirrors traditional software. Developers must now systematically test their skills, benchmark execution, compare output data, and decide if the component deserves to stay. This transition moves AI development out of the realm of human intuition and into the discipline of empirical software engineering. Historically, creating a skill was informal. You wrote out your logic, pasted it into the model, and simply hoped it would apply the rules correctly. And this created a persistent cognitive trap. If you ran a prompt and the text looked superficially cleaner, you assumed your custom logic was the reason why. Tweaking a prompt and hitting generate again creates a fast iterative loop. It is also messy and often misleading. A handful of successful runs often mask a high overall failure rate. It is easy to convince yourself a skill works by unknowingly looking at cherry-picked outputs. The risk is that you retain a custom skill in your stack that silently degrades the model's performance across every other task. Anthropic is solving this by introducing built-in evaluations. The platform stops acting like a prompt playground and starts functioning as a dedicated development environment. The system allows you to define standardized test suites that verify exactly how the skill behaves across hundreds of runs. This dashboard shows the concrete metrics the system now tracks: pass rate percentages, execution time latency, and exact token usage per run. Firm. The standard is now a binary. A skill either improves the output according to the data, or it does not. This requires a mindset shift from the developer. Emotional defense of a prompt has to stop. Every addition to the workflow must guarantee measurable performance. Once developers have access to measurements, they can abandon personal attachment and build reliable systems. The core architectural mechanism driving this new evaluation standard is the automated comparator agent. Conceptually, the comparator acts as a blind judge. Its purpose is to remove human bias from the testing loop. The workflow starts by taking the exact same input prompt and executing it under two different operational conditions. One execution path relies on the base model. The second routes the prompt through your custom skill. Next, outputs from both paths are stripped of all identifying metadata before being submitted for review. Blind review is necessary here. Developers want the tools they spent hours building to win, which introduces bias into manual testing. The comparator scores the outputs based on the quality of the final result. It has zero visibility into the setup that generated the text. Introducing algorithmic double-blind testing is a major improvement to the AI development pipeline. It also exposes a reality. Many legacy skills that developers assumed were carrying weight will fail this objective test. An algorithmic double-blind evaluation is the only way to show that a custom instruction actually adds value, rather than adding latency. We also have to look at the activation layer. The logic of a custom skill is useless if it fires at the wrong moment. Bad triggers introduce latency waste if they fire early and cause system failure if they stay silent. Anthropic's automated optimization loop generates realistic prompts, tests reliability, and rewrites vague descriptions until the routing logic is airtight. This establishes an uncompromising rule for this standard. A skill that cannot demonstrably beat the baseline is system baggage. This brings up a major long-term threat to system architecture: the obsolescence of custom instructions over time. As foundation models natively improve, they eventually learn to handle the complex tasks that previously required custom rules. When the base model catches up, keeping legacy skills becomes a liability. They transform from functional enhancements into architectural constraints that box the model in. Outdated skills damage your outputs by enforcing old, narrow patterns onto newer, highly capable base models. The required action is clear. If the base model begins passing the evaluation tests without the skill must be deleted. Developers are comfortable adding complex layers to a system, but they are often resistant to tearing them down. Deleting a once useful custom skill is not a failure of your initial engineering, it is healthy system maintenance. The chronological setup of the new evaluation flow is structured. You define your test prompts first, and then describe what a successful output looks like. In the secondary setup phase, you inject any necessary files or extra context directly into the evaluation pipeline. During the parallel execution phase, the system simultaneously runs multiple agents, varying the presence of the custom skill across the test batch. Finally, in the review phase, the comparator agent checks all outputs against the success expectations you predefined. This evaluation report interface illustrates the final output of the pipeline. It maps quality scores directly against token costs. Reviewing an evaluation is a study in system economics and architectural trade-offs, far beyond hunting for a high pass rate. A skill that marginally improves output quality but doubles your API costs in the process is likely an economic failure. Similarly, a skill that executes rapidly but degrades the reliability of the system is not worth keeping in production. Looking at the macroscopic view, this single update represents a shift in how AI workflows are managed. This disciplined loop of writing, testing, measuring, and deleting connects to practices in traditional software shipping and long-term system maintenance. AI tooling is maturing from unmeasurable demos into testable infrastructure. From this point forward, every custom skill must demonstrate a clear, measurable advantage to justify its place in the system.